Good evening all. I'll move to the next topic. So here, what is the status of the time here? What is the condition of the time here? For all my activity, if we see, there is a specific time is given. For example, if I want to perform activity A, it requires 4 weeks, B it is 10, C it is 6, okay, E it is 4, like that. Definite time period is given for each and every activity. Okay, for every activity, we have given an exact time. Okay, the exact time is given. If I don't know the exact time, what will happen? There are certain uncertainties are there in the project. Based on that uncertainty, my project may complete in this most likely time. If the things all are worse, it may end up a larger time than this. Suppose if all the things are went well, okay, went well, then this time might not be required to complete my task or complete my activity. In that case, what will I do and how will I proceed? That is, instead of given an exact time, okay, exact time, my time has got a probabilistic change, or my time is going to change in the condition as pessimistic time, optimistic time, and most likely time. The three conditions. That is, if all the things went well, okay, than what I expected. Of course, the optimistic. Okay, things are neutral, and then it will end up in a most likely time. All the things are worst, then I will end up in the other way, the pessimistic time. So, how to approach such problems? So that is what basically, okay, that is what is basically the model called as PERT deals with. Okay, that is what is actually the model PERT deals with. So the next topic is PERT. So PERT. So the expansion is program evaluation and review technique. Okay, so program evaluation and review technique. So that is called as PERT. Okay, so in short, it is called as PERT. So PERT, okay, so normally it will deals with three set of time. As I told you, one is called optimistic time. Okay, one is called optimistic time. The next is called most likely time. Most likely time. And the third is called pessimistic time. See, that is, for example, okay, so this is one end. Okay, this is one end. This is the other end. Okay, and this is the third, this is the middle is the next one. That is a three time. So the first one is the optimistic. Okay, so the first one is the optimistic. Okay, most likely and pessimistic time. So optimistic time normally will be represented as T naught. Okay, T naught. Or some books they will be representing it as A. So the most likely time it will be marked as TM or B. Sorry, AMB. Sorry. So that is M. And pessimistic time, so that will be marked as TP or B. So this is T naught or A. This is TM or M. This is TP or B. So these three time estimates will be given to you. Okay, if you don't know the exact time of individual activities. So this is basically here in this axis it is time. Okay, in this axis it is time. Now, when you given a condition like this, you need to calculate from this three time estimates TM, T naught, TM, TP or AMB. You need to calculate the expected time. Okay, so you need to calculate from this the time called as expected time. Okay, the time is called expected time. So that will be marked as TE. So TE will fit normally somewhere here. Okay, so normally somewhere here your TE will be fitting. And the equation for calculating the TE that is already arrived. So TE equals, that will be T naught plus 4TM plus TP whole divided by 6. Okay, so TE is the time expected time. So from this three time estimates, you need to convert that into an expected time TE by using this formula. When once this formula you are using and you are converting that into the expected time, then the procedure remains the same. Okay, then the procedure remains the same. Is that clear? Is the idea clear? So the three time estimates will be given to you. So using the three time estimates, you need to calculate the expected time by using the formula. Okay, by using the formula and then construct the network diagram, calculate the project duration as is specified like in the CPM method. But here no need of any calculation of the floats etc. and no crashing of network also you don't need to bother in the case of PERT diagrams, in the PERT network models. Because already that your expected time is likely to change. Okay, already the three time estimates are given. So the calculation of floats as well as the crashing the network. Okay, you don't need to bother in the case of PERT models. So from the three given time estimate, you need to calculate the expected time, and using the expected time, you can calculate. Okay, you can calculate the project completion time. And also you can calculate the estimates like standard deviation or variance, okay, or variance etc. from this model. Okay, since it is a probabilistic approach is employed, so TP minus T naught by 6. Okay, gives your standard deviation, variance you can calculate. Okay, so all the variance is sigma t square. Okay, you will get the variance. Likewise, you can calculate. Okay, you can calculate the project duration, you can calculate the standard deviation, you can calculate the variance, and using one table here you can able to say that for a particular period what is the probability that this project is going to complete. Okay, so that also will be a part of this PERT model. So I'll give you a small problem for you to practice so you'll get the clear idea in this regard. So activities are listed there. You can construct the network diagram. Yeah, so that is the question. So construct the network diagram. So construct the network diagram. Okay, calculate or compute the project duration. Okay, also calculate the standard deviation. And variance of the path. Okay, so that's the question is. So the equation for calculating T is given. So calculate, and parallelly you can draw the network diagram also. So this is 1, 1 to 2, 1 to 4, 2 to 3, 2 to 3, 3 to 5, 5 to 6. So 1 to 2, 1 to 4, 2 to 3, 3 to 5, 4 to 5, and 5 to 6. Yeah. What is the TE values for the first case?
5.
Okay. Second one.
1.
Okay. Next one.
4.
Next one is 3 to 5.
4.
4. 4 into 6. 4 into 6 plus 18 divided by 6. 0 plus 4 into 6 plus 18 divided by 6.
7.
Yeah, that's 7. Okay, next one. 7. Next one. That's also 3. Last one is 8. So 1 to 2 is 5. 2 to 3 is 1. 3 to 5 is 7. 1 to 4 is 3. 4 to 5 is 8. And 5 to 6 is 7. Then after this you can use our whole rectangle triangle model for computing the project time. So 0 here, so 0 plus 5 is 5 here, 5 plus 1 6, this is 3, so 6 plus 7 is 13, 8 plus 3 is 11, so 13 is larger, 13 plus 7 it is 20, so 20 here, here it comes as 13, so here it comes as 6, so 13 minus 8, how much? 5, so here it is 5, so 0, 5 minus 5 is 0 and 5 minus 3 is 2, minimum is 0. I have written the 0 over there. So project time is calculated. We have find the project duration. We have find the critical path also. So critical path is marked by thickening the line or drawing a double line over it so that the path can be identified. Now, what is the standard deviation and variance? Sigma t and V of T. So sigma T equation already I given you. So that is Tp minus T naught by 6. Yeah, so get me the value 1 0 3 0 0 and 2. Here it is 0, sorry, 1 square, you will get the variance 0 9 0 0 4. Is that part clear? Now there is a question. Question is something like this. So go to the next page. So I had this 3 time estimates. So for example, the same time estimates what I have taken. So T naught, Tm, and Tp. So there are two. So this 3, 6, and 7 by an engineer 1. And engineer 2 also gives a similar time estimate 4, 5, and 9. Okay. Now the question is, who is more certain? Okay. Who is more certain about the time completion of the job? About the time completion of the job. That is a question. So how do we find it? Who is more certain about a job? So these are the, yeah.
We'll find expected time, sir. Then we'll
Okay.
just compare it with most likely time, which is
Okay.
nearer. We'll prefer that guy because
Yeah.
it he is certain about the meaning only says no, sir. In
Yes.
this case, engineering answer is the answer.
Yeah. Okay. Right. As you told, it is correct. So we'll find the variance. Okay. So we'll find the variance. So sigma a square. So that is Tp minus T naught. Okay. Divided by 6 the whole square. Okay, so for both the case, sigma a square, similarly we'll calculate sigma b square also. So when we calculate the sigma a square, the value you will get it as 0.444 and sigma b square will be 0.694. Okay, so lesser the variance. Okay, so lesser the variance is preferred. Okay, lesser the variance is preferred. So engineer A. Okay, you told it correct. So engineer A. So lesser you have to calculate the variance and compare it. So lesser the variance, so that will take it as the best. So that is the way you can get it like that. Okay. Now I'll give you another question also. So the question is, a project is expected to take 12 months along the critical path. Along the critical path, having a standard deviation of having a standard deviation of 4 months. Okay, having a standard deviation of 4 months. So what is the probability that first is completion of project within 10 months. Okay, question number B, completion of project within 16 months. And question number C is completion of project within 8 months. Yeah. So how to determine? So how to determine it? Completion of project within 10 months, completion of project within 16 months, completion of project within 8 months. So how will you determine it? See, first you have to calculate the Z value for that case. Okay, so I'll take the first case. Okay, so I'll take the first case, example A. So Z value you can calculate using the equation Ts minus Te divided by sigma. Okay, divided by sigma. Okay, what is the Ts value? Ts value is our asked value. So 10 for the first case it is 10. And expected time we have already given in the question, it is 12. So 10 minus 12 divided by sigma is also given in the question 4. So what is the value you will get? You will get it as minus 0.5. Okay. Same way you can calculate it for B also. Z. Okay. Same way. So 16 minus 12 divided by 4. So you will get it as how you will get it as 1. And the next case for C. So next case for C, again Z equals So 8 minus 12 divided by 4. So you will get it as -1. Okay. After finding the Z value, you have to go to the normal distribution table. Okay. You have to go for the normal distribution table. So table will be available in book or it will be available in net also. So I'll show you a sample one. I hope that my screen is visible. But the data. So what is so for which set value are we determining? We got it as minus 0.5. Yeah. So for minus 0.5, what is our value shown here? 0.5. What is our value shown here? What is the value shown here? It is 0.1915. Am I right? So 0.1915. So whatever may be the case, okay. So whatever may be the case, from the table we got the value as 0.1915. So what you have to do is that if you got a value like this, okay, so you have to, since it is minus sign, it will be 0.5 minus 0.1915. What is the value? What is the value? What will be the value? Value will be 30.85%. Okay. So for the first case, Z of 0.5 is 0.1915. Okay. So this 0.5 will be always a constant. This 0.5 will be always a constant. And plus or minus will depends on the sign here. Okay. The plus or minus will depends on the sign here. And this you have to enter over here. Okay. Now just get me the value of Z of 1. Z of 1. Z of 1 is 0.3413. Can you see in the table? 0.100. Okay. So this is 0.1. Okay, this is 1. Okay, 1.00. That's why I'm taking here. If it is 0.55, this is 0.5 and 0.5 is here. So 0.5, 0.05 value will be this. Okay, if it is 1.25, this is 1.2 and in the fifth column. So 1.25. So like this, this is 1.00. So the value is 0.3413. Agrees? 0.3413. So what you have to do is that normal distribution table, you got the value as what was our value? 0.3413. Okay. For our case number B and C also, this is +1, this is -1. So B, it will be 0.5 plus 0.1915. 0.15. Sorry. Plus 0.3413. And for our case number C, it will be 0.5 minus 0.3413. What are the values? This is 84.13%, and next is 15.87%. So you can see, so 0.5 is a constant, so that will be there in your table. So the value you have to plus or minus, depends on the sign you are getting over here. If it is plus, you have to add 0.5 to it. Okay, if it is not, if it is negative, you can subtract that 0.5 minus that value from your table. Suppose here I given the sigma value like this. Okay, the sigma is given directly. Okay, if not given, what will you do? If it is not given, what will you do? What will you do? See, option number 1. Okay, you can go for the largest. Okay, you can go for the largest sigma value in the largest sigma value from the calculation. Okay, largest sigma value from the calculation. See, for example, in our previous problem, not in this, yeah, in this previous problem. Okay, so you can see the largest variance is, so the largest sigma value is 3. You can go for that, option number 1. Option number 2, my path is 1 to 2, 2 to 3, 3 to 5, and 5 to 6. So 1 to 2 is 1. Okay, so 1 plus 2 to 3 is 0. 3 to 5 is 3. So 4. Yeah, so 1 plus 9 is 10. Then 5 to 6 is also 0. So 10. So square root of 10 you can take. Okay, you can compute the variance. So option number 2. Compute the variance of critical path. Variance of critical path and square root it to get sigma. Okay, you can use any of these two methods if it is not given. Okay, or if you have been asked to compute, either take the larger sigma from the calculated value, or you can take the square root. So if you can see in the previous, if you take the previous, it will be 3 the largest one. Root of 10 is also 3. Any one of the approach, and whichever approach you are following, please indicate it in the problem solution part. Okay, in your problem solution part, please indicate it which method you are following.